Hi guys and welcome to this lecture. So in the last lecture we went through the interface of Vivado, and now what we're going to do is we're going to create the VHDL code, a very basic set of code, and then we're going to simulate that code. Okay, so let's get started. Okay, so this is the code where we have our library declarations over here. We declare the IEEE standard logic library. And then we have our entity. This is our input and output declarations, or where we have the A and B inputs and our C output. We're going to AND A and B to get C. And in our architecture, this is where we put in our process or concurrent code. Let's type in some basic code. So we're going to say C, a small c. So we're going to put A and B. Don't forget your semicolon, very important. Okay. So what this will do is it'll take our A and B, and then the output will be C. If you want to know what the output will be, you can take a look at our AND gate. So we're expecting if we put 0 and 0, our output will be 0. If we put 0 and 1, it will be 0. Same thing with this one. But if we put 1, 1, then our output will be 1. Let's test this in simulation to see if we are correct. Now, before we can implement our simulation, first we need to create a test bench. Now, a test bench is basically a set of code that we can use to fill in our inputs and then monitor our outputs. So let's go ahead and create a test bench. So we go to add sources, create simulation sources. Next, create a new file. And we're going to call this and_TV, where TV stands for test bench. Click finish. We don't instantiate any port names as yet. I'll tell you the main reason for that in a moment. Okay, so we need our AND gate software to fall under this test bench. So if you open up this test bench, you'll see it has very basic structure or skeleton structure for this. Normally you can write it yourself, you can write your own test bench, but I prefer to copy all this code, Control and C, and then we go online and we look for a test bench generator in VHDL. I like to use the first one, which is the one by Dulos. Okay, so you can take that code, select all, and paste it into there. And then you click Generate VHDL Test Bench. You can close this one in the meantime. And there we go, we got our test bench. So select from over here down to AND. Copy that, Control and C. And then if you go to our test bench, delete all of this, and then copy our code onto there. Alright, so if you press Control and save, you can see that our test bench has become the parent of our AND gate. So this is the input to our AND gate main program. Okay, so let's write some code to stimulate our block over here. So first, let's initialize our inputs. So what I did over here was I said, okay, if you put a logical 0, let's put that into A. And now we copy that and put it into B also. So we're making at time equals 0, A must be 0 and B must be 0. Now we'll say, okay, let's wait for 10 nanoseconds. Wait for 10 nanoseconds. Don't forget your semicolon. Okay, now basically what you can do is copy this a few times so we can test all combinations of this. So we'll make this 1, this will be 1, 0, and then this will be 1 and 1. And then right at the end we can put 0, 0. Okay, so now we're testing for all combinations of A and B to see what the output of C will be in any case. So Control and save. Control and save does a mini compilation so you can see if there's any errors in our code. Okay, so first let's run our simulation. First save this. If there's a star on top there, it means it's unsaved. Okay, so we synthesize our code, run synthesis, and see if there's any errors. Okay, so it says synthesis successfully completed. We don't want to run implementation as yet because we're not ready as yet. We can open up synthesize design, but I'll open up just a little while. Click cancel. Okay, now we can go onto our simulation. Go to run simulation and let's see what we get. Run behavioral simulation. Okay, so we got our simulation. Just make this bigger. You can, if you want, make this a floating window so that you can see a much bigger view of the input. So let's start our simulation. We're going to run it for 5 microseconds, which is more than enough. If you go to the beginning, drag it all the way to the beginning, and let's see if we get anything. Ah, there we go. So when A and B are 0, we get nothing on the output. When A is 1 and B is 0, we get nothing on the output. Same with this condition over here. But when we have A and B both on, then C is on as well. Let's just take a look at our table that we have. If you look at our table, it confirms our calculation. If 1 and 1, it means it's on. Now, what I want you to do is try this on your own, but use an OR gate and see what result you get. The test bench will be exactly the same. Okay, so before we end off this lecture, let's open up our synthesized design. Let's see what we get. Okay, so over here it shows you the layout of the FPGA. You can check the different blocks. If you zoom in, you'll be able to see some individual flip-flops and logic gates or lookup tables. You can see the slices over here. Okay, to see exactly what's happening, let's go to our schematic. Okay, so this is what we generated from our code. A and B go through a buffer, and then that goes into our lookup table, and then it gets buffered out, and then our output is C. Okay, so that is it. There's a lot more that we should go through, but we'll only go through the main concepts that we need to get going as quick and simple as possible. Okay, so in the next lecture, what we're going to be doing is we're going to implement our design and we're going to create our constraints. The first set of constraints will be the pin layout. If the pin timing is not correct, we can go into the timing wizard and correct our timing as well. Okay, so that's it for this lecture. I'll see you in the next lecture.